Thank you so very much. I'm really delighted and honored to be here and will share with you in the next 20 minutes the top stories in medicine in the last century. Now, I won't be able to do justice to all the top stories, so I'm going to limit this talk to about 5 or 6 top stories. And then in the last 2 minutes, I'm going to predict what will happen in the next 50 years in medicine. So a lot of the discoveries in medicine, the discovery of hepatitis B, the discovery of penicillin, were pure serendipity, chance in the prepared mind. And the word serendipity comes from a story called The Three Princes of Serendip, whose heroes were always making discoveries by accidents and sagacity of things they were not in quest of. Louis Pasteur once said, in the field of observation, chance favors only the prepared mind. So I'm going to talk about the discovery of hepatitis B and the first anti-cancer vaccine, cholera and oral rehydration therapy, organ transplantation from the first kidney transplant in Boston at Harvard in 1954 by Dr. Joseph Murray, medical imaging from the first X-ray to molecular imaging, Alexander Fleming and the discovery of penicillin, the pill. If I say the word the pill, everyone knows what I'm talking about. And from polio to AIDS, 2 devastating epidemics. Not going to have time to talk about many other amazing discoveries, such as the cardiac pacemaker, the discovery of insulin by Banting and Best, the most common chronic infection in man. You might be surprised to hear more than 3 billion people have this infection. It's called Helicobacter pylori, leads to peptic ulcer disease. And the person who discovered that, Barry Marshall and Warren Robin, got the Nobel Prize in Medicine for that major landmark discovery. We're not going to talk about the Human Genome Project. We're not going to talk about consciousness, except I'm going to make one comment at the end. Now, the discovery of hepatitis B was also serendipity. Baruch Blumberg, who's a geneticist, he's not a virologist or a hepatologist, had an interest in the study of polymorphic serum proteins. And that interest led to the very serendipitous discovery of what he called Australia antigen, which we now call hepatitis B surface antigen. E.B. Ford, an Oxford geneticist and zoologist, defined polymorphism as the occurrence in the natural habitat of 2 or more discontinuous and presumably inherited forms of a species in such proportions that the rarest of them cannot be maintained forever merely by recurrent mutation. And examples of polymorphism abound in human biology. And Dr. Blumberg had an interest in polymorphic serum proteins, and this led to a chance discovery. He actually published a paper in JAMA in 1965 called A New Antigen in Leukemic Sera. He thought he'd found the cause of this kind of leukemia, or a marker for this condition. In retrospect, these were leukemic patients who needed blood transfusions, and some of them had become saddled with chronic hepatitis B infection. There was no test to detect hepatitis B in donor blood. Then by chance, one of his technicians had tested herself for hepatitis B for Australia antigen. She was negative. One day she's not feeling well. She has jaundice, she has acute hepatitis. She tests herself, she's positive. She recovers. She tests herself again and she's negative. So Dr. Blumberg called the Philadelphia area physicians and said, when you see a patient with jaundice or acute hepatitis, would you please send me a sample of their blood? And lo and behold, that was the discovery of hepatitis B. It's a wonderful story, and if you really want to read about it, read the July 77 issue of Science. It's Dr. Blumberg's acceptance speech for the Nobel Prize in Medicine or Physiology that he received in 1976. This is the actual hepatitis B virion, a 42 nanometer particle called the Dane particle. And now we know the epidemiology, we have treatments, but we also have the most wonderful vaccine against hepatitis B. 2 decades of universal vaccination in childhood in Taiwan led to the prevalence dropping from 15-20% to 1.5%. And 2 decades of universal vaccination in children led to a 75% decrease in primary liver cancer mortality. So it is truly the first anti-cancer vaccine. Now, the second story I'm going to talk about is that of cholera. Sushruta, a very sage Indian physician, way back in 600 BC, advocated the C-section removal of kidney stones and cataracts. He also cataloged more than 100 surgical instruments. He also had an excellent description of a disease resembling cholera. This sage person said many years ago, "May God be with me. May heaven bless this new year. May it be a year of fruitfulness, of peace and prosperity. May it be a year of peace and unity for all mankind. May the world be freed of cholera." There were 2 seminal observations in the early 60s. The first was the discovery of the sodium glucose co-transport as the mechanism for intestinal glucose absorption. So in cholera, the GI tract has turned into a secretory organ. It's putting out a liter of stool every half hour, every 1 hour. Patients get massive dehydration and die. It's been called a disease which begins where other diseases end, with death. And this discovery that the intestinal mucosa was intact, and while it was a secretory organ, it was still capable of absorbing fluid and electrolytes. And you added a little sugar, a little Coca-Cola, it enhanced the absorption. And implementation of oral rehydration therapy has saved more lives than all the antibiotics put together. So a very important discovery. Now, this is the tragedy that occurred in Haiti in 2010. Cholera was unknown in Haiti before the earthquake. Now there have been almost 1 million cases of cholera and 8,000 deaths. This is a patient in Bangladesh many years ago who was so moribund he couldn't get oral rehydration therapy, so he needed intravenous resuscitation. And for this one single patient, you see all the IV bottles he's surrounded by, he needed 150 liters of fluid resuscitation. The third story I'm going to talk about is about the first kidney transplant by Dr. Joseph Murray from Harvard Medical School, Peter Ben Brigham Hospital. He got the Nobel Prize in medicine in 1990. He died about a year ago at age 92, a very humble man. When he got the Nobel Prize, he was asked, "Did you do that first kidney transplant for the history books?" He said, "No, all I was trying to do was save one patient's life." And what happened is that there were 2 identical twins, 23 years of age, Ronald and Roland, and Ronald had end-stage kidney disease. So they go to meet Dr. Murray, and they say, Roland says, "I can give one of my kidneys to Ronald." And Dr. Murray said, "Listen, we are still working on immunosuppression. We're not ready yet, maybe in 2 or 3 years." And they say to Dr. Murray, "But we're identical twins. Maybe the kidney won't reject." So they send them to a police station because back then they thought that identical twins had identical fingerprints. And so they send them to a police station to get fingerprinted. While they're there, there's a newspaper reporter doing another story. He gets wind of it. He writes an article. Dr. Murray is attacked by physicians, by ethicists. What are you doing? You're trying to play God. He does the kidney transplantation, no immunosuppression. Ronald lives for 9 years without immunosuppression, marries one of the nurses at the Brigham, has 2 children. And Roland lives for another 54 years, dies at age 77. These are the important milestones. The first successful kidney transplant in 1954, the first successful liver transplant in 1967, heart transplant in 68, pancreas transplant also in 68, heart-lung combined in 1981, living-related liver transplants, 1989, full face transplant, 2012, and a kidney transplant chain, which is a fascinating story, but I don't have time this morning to talk about it. But it I'll tell it to you briefly. This was an individual who had just embraced Buddhism. And he goes to a gym and he finds out that the secretary had been away for 2 months. So when she comes back, he discovers she had given a kidney to a friend. So he goes to a local transplant center and says, I want to donate a kidney. So they type and cross-match him and they say, there's no appropriate recipient for you. He says, if you don't have an appropriate recipient for me at this center, why don't you take my kidney and give it to somebody deserving in another center? And this started a chain, 60 individuals, 30 donors, 30 recipients, inextricably linked, carried out over 4 months in 17 hospitals in 7 states. And these are the amazing 30 donors and 30 recipients. The next story I'm going to talk about is medical imaging, from the first X-ray to molecular imaging. William Röntgen was a physicist and discovered the first X-ray, and this is the actual first X-ray ever taken. What do you see? You see a hand. And what's that ring? It's the wedding ring of his wife. That was the first X-ray. Now we have CAT scans, MRIs, PET scans, functional MRI, which is how we are studying consciousness and meditation. The first CAT scan was invented in 1972 by British engineer Godfrey Hounsfield and South African-born physicist Alan Cormack of Tufts University in Boston. And they got the Nobel Prize in 1979 for that major discovery. It's changed the way we practice medicine. EMI was Electric and Musical Industries Limited, and they were an investor in airborne radar, CT scanners, and one other thing. Anyone know? EMI? The Beatles. And they made so much money from the Beatles, they invested it further into medical imaging. And now we're at the stage where we can link gene expression and imaging traits. Every tumor has a unique molecular signature. We can discover that on pathology, but now we're actually able to see it on imaging, molecular imaging. Different imaging modalities shown on this slide: contrast ultrasound, CT perfusion mapping, functional MRI, PET scanning, and optical imaging. The next story I'm going to talk about is the story of the discovery of penicillin. Alexander Fleming had served as a lieutenant in World War I and noticed that antiseptics used by Lister had no effect in systemic infections. Over 10 million soldiers died in World War I. He goes on a vacation, family vacation, and he comes back, and he's actually disgruntled because there are a lot of Petri dishes lying in his lab, which one of his assistants was supposed to discard. So he picks one of them, and he's looking at it. It was a warm summer night, 1928, and he notices that the staph, the bacteria, had grown, but there was a fungus, a mold, contaminating the Petri dish, and around it was a zone of inhibition. The bacteria couldn't grow there. The mold is making something to kill the bacteria. Now, most scientists would have taken that Petri dish, discarded it. This is spoiled, it's ruined. But he pursued the development of penicillin. He was not a chemist, and he actually gave up. 12 years later, in 1940, second year of World War II, 2 individuals, Howard Florey and Ernst Chain. Howard Florey from Australia, Ernst Chain was a German chemist, a refugee, and they developed synthesized penicillin. They then took 8 mice and gave them a virulent form of streptococcus infection. 4 of the mice were given penicillin. 17 and a half hours later, the 4 mice that did not get penicillin were dead. The 4 that got penicillin were alive. So this was the landmark paper in The Lancet in 1940. And the 3 of them, Alexander Fleming, Howard Florey, and Ernst Chain, got the Nobel Prize in Medicine for that major discovery. The next topic I'm going to talk about is the pill. And the story starts with Margaret Sanger. She was a nurse, an iconic figure, In Holland, she learned about diaphragms and wrote a book, What Every Girl Should Know. She actually coined the term birth control pill and was the founder of Planned Parenthood. But she was attacked. She was actually sent to jail. She was interfering with the work of God. And then John Rock, a physician, signed a petition in 1931. There was a petition protesting law prohibiting contraception. He was the only Catholic doctor to do so. And he once said, always stick to your own conscience. Never let anyone keep it for you. The birth control pill was approved in 1957. It was approved for menstrual irregularities, not for contraception. And guess what happened? Millions of women in America had menstrual irregularities. If you want to read more about it, read about it in What the Dog Saw by Malcolm Gladwell. In The Economist in 1999, it said, there is perhaps one invention that historians 1,000 years in the future will look back and say, that defined the 20th century. That invention is the contraceptive pill. Margaret Sanger wanted women to have birth when they wanted to be part of the workforce, and not subject themselves to back alley abortions, which were often fatal. In the next minute, I'm going to talk about two epidemics, from polio to AIDS. Here's a wonderful lithograph from Egypt, and you can see that one of his legs is markedly withered. He had polio. They depicted polio. We had iron lungs. FDR had polio, but most of the time, most of the Americans in our country never knew about his polio. He was propped up. It was only later in life that he decided to show himself in a wheelchair. And he engaged Eddie Cantor, a comedian, to start the March of Dimes. This was the first large-scale national effort for funding. And instead of investing in iron lungs, they invested in the development of the vaccine. You all have on your dime FDR, March of Dimes, his emblem. John Franklin Enders entered Harvard to study English literature, Germanic and Celtic languages. And together with Frederick Robbins and Thomas Weller, they were the first to develop tissue culture that grew viruses. And they published a paper in Science, and shortly thereafter, they received the Nobel Prize, Tom Weller, Frederick Robbins, and John Enders. And virtually, polio has been eradicated from the world. But then a new epidemic emerged. And a paper came out in 1981. It said 5 patients with opportunistic infections, no identifiable cause. An article in Morbidity and Mortality World Report, Michael Gottlieb said, I knew I was witnessing medical history, but I had no comprehension of what this illness would become. By 2007, 33 million infected worldwide, 6,800 new cases a day. In 1983, a T lymphotropic retrovirus was isolated from a patient with AIDS and lymphadenopathy. And this was the first trial showing that AZT, a pill, increased the CD4 count, and these patients did better. This was the first reported trial of combination therapy. And look what used to happen. Patients would have to take multitude of pills. Now they take one pill. One pill a day, and they're alive 20 years later, 25 years later. A picture's worth 1,000 words. This young kid dying with AIDS, and now on antiretroviral treatment, living a healthy, robust life. So I'm going to finish in the next minute, Deepak, by predicting the next 50 years. Niels Bohr, the physicist, Nobel laureate, once said, prediction is very difficult, especially if it's about the future. So what's going to happen in the next 50 years? There will be vaccines to prevent Alzheimer's, malaria, TB, HIV, hepatitis C, celiac sprue, and many cancers. Regenerative stem cells will replace organ transplantation. Patients will take a pill that will mimic exercise. and combat the metabolic syndrome. The yoga pill. Bariatric surgery for morbid obesity, the number one general surgical procedure in the hospital I work at in Boston, will become a historical footnote. Imaging technology and biomarkers will enable early identification and aid in eradication of tumors. Immunotherapy will be the key to cancer treatments and cut cancer mortality by over 50%. Nanotechnology and nanobiomedicine will flourish and permit more precise diagnosis and targeted innovative therapies. Innovative and disruptive technology will permit trained non-physicians to manage a host of chronic disorders using mobile devices. Democratization of knowledge will occur. Supercomputers will allow citizens to access health information. Non-invasive sensors in our clothes will monitor a ton of information. Healthcare will be available and affordable for all US citizens. And primary care medicine will be celebrated as the hero's profession. Life expectancy in the United States will exceed 90 years. I was very inspired yesterday sitting in the audience and listening to the talks, so I'm going to have one more prediction. And that is that the Consciousness Project will yield masterful insights and serve humanity in unprecedented ways. Thank you very much for your attention.
So, hey, Rudy. So, since he's my brother, we're going to exercise a little nepotism here and go a little over time. You can see that left brain, right brain, same family. And as I mentioned before, he's the Dean of Education at Harvard Medical School. And I think this is a moment for both of us. Talk about Daddy.
So Deepak is getting emotional, as am I, thinking about the wonderful heritage, the wonderful core values and principles that were instilled into us by our parents, our grandparents, our uncles, the great storytellers. I decided to go into medicine. Some of you may have read about this story, because at age 12, I'm studying in St. Columbus High School in New Delhi. Deepak is 2 years older. I play a cricket match. I take a nap. It's a Sunday around 5 o'clock. For about half an hour, I wake up, and I'm blind. I cannot see. I'm totally blind. So I nudge Deepak. I said, Deepak, I can't see. He starts crying. He says, I have one brother. He's turned blind. They take me to a military hospital in Delhi, and the doctors are clueless. They don't have an idea. No idea. Not the foggiest idea as to why I can't see. There's even talk of hysterical blindness. Meanwhile, I'm this happy kid, a very good student, great athlete. And they track my father down, our father down 300 miles away. And he was an amazing physician. He was a cardiologist, but he knew all of medicine. And he said, tell me everything that's happened to Sanjiv in the last 2 months. So this has been fine. No, tell me everything. Any new medicines, any injuries? Yeah. He had an injury to his leg, a laceration, and we took him to the hospital. He got stitches. Did he get an antibiotic? So they looked up the records and said yes. Then he asked one more question. Did he get a tetanus shot? And they said yes. And he said, what kind? This is 1961. Anti-tetanus serum or anti-tetanus toxoid? And they looked at the records and they said anti-tetanus serum, ATS. And our dad said, he's having a severe, rare, idiosyncratic reaction to the anti-tetanus serum. It occurs less than 1 in a million. He has severe bilateral optic neuritis. His optic nerves are totally inflamed. Start an intravenous and give him massive doses of corticosteroids. And they did that, and about 4 hours later, my vision returned. And that was the day I decided I wanted to be a doctor, wanted to be a physician like my father.
So that was our father. he was both right brain and left brain, you know. And in many ways, the Consciousness Project is the corpus callosum that's going to bring together the right brain and the left brain. They don't have to be at odds with each other. So one of the things that really fascinated me about this talk, and brilliant talk, and about the future as well, is that almost every discovery was what you call serendipity. So one of the attributes of consciousness, and which we've discussed many times, is that consciousness is unpredictable. Consciousness is serendipitous. Consciousness proliferates in the wisdom of uncertainty. And that is what is happening. The creative process, the innovations, the quantum leaps in context, in meaning, in relationship that lead to these extraordinary discoveries are, in fact, what mechanists would call randomness, but what people who understand consciousness is what randomness is only apparent randomness. It's the creative process. So here I see great opportunities for the Consciousness Project to create major discoveries if we are open to the mechanics of serendipity, to the mechanics of chance, to the mechanics of the creative process. And there is no reason for mainstream medicine or even reductionist medicine to feel in any way that a deeper understanding of consciousness is, in fact, in any way antagonistic to the materialistic paradigm. It is not. It will only make these discoveries even more favorable in the future. So Sanjiv, do you meditate?
Yeah, I do. So I meditate usually twice a day. I wake up at 4 in the morning. I meditate for 45 minutes. I share with all my patients and my friends. There's a wonderful ancient saying, you should meditate once a day, and if you don't have time to do that, you should meditate twice a day.
Thank you.
Talking about serendipity, I've actually thought about this and had this discussion with many of my esteemed colleagues at Harvard Medical School. How do we actually have serendipity flourish? And I think one way is to find that silence, to meditate. The other is to sit under the shade of an apple tree. Right? And the third is to have the courage to dare to dream big. One of my favorite quotes is from Søren Kierkegaard, the Danish philosopher and theologian, who once said, to dare is to lose one's footing momentarily. Not to dare is to lose oneself. So find yourself, find your creativity, and change the world. Thank you very much.